My name is Aiman, and now I'm going to explain the problem statement of our case study. So as we can see, the table shows the result is like how we're gonna do is that we gonna switch the alphabet to the number, which this like the method is called alphanumeric substitution, where we switch each alphabet into the number. So for example, like A equals to 1, or B equals to 2, C equals to 3, and then it goes on until to Z to 27, which is 26, sorry. And then we're going to also apply a spaces. There is some sentence where there is a space between each words. We're going to put number 0. So like in this case, we got linear algebra, which is there is a space between those two words. So we're going to put 0 in the middle. And then the last one, we're also going to put number 27, which indicate the dotted line, which if you realize linear algebra and then dotted. So we're going to put number 27 for the dotted line. So after we change the word into the numeric form, this is what we're going to get, which is, I don't know if you can see it clearly. As you can see, linear, which is, we change it to the numbering, so you can see L equals to 12, and then it goes on. And then we put number 0, since there's a space between two words, and then and the algebra, which is, and again there's a dotted line, so we're going to put number 27 on the dotted line. And then next, after we already switch all the words or the alphabet into the number, we're going to put it in the matrix with a column of 3, and the matrix is going to look like, bear in a minute, and the matrix is going to look like this. This is how the matrix looks like. So it's basically from the numbering that we got, we're gonna like order it. So 12, 9, 14 until 27. Yeah, just now we show there is all the 12, 9, 14, 5, 8, all the numbers, include 0, include 27 just now. We're gonna put all it. So okay, that's my part done, and now we're gonna switch to how we're gonna solve the problems. Thank you very much.
Okay, Assalamualaikum warahmatullahi taala wabarakatuh. Right now you are with me, Zairil Izahan. So in this part, I will explain to you how can we solve the problem by using linear algebra in cryptography. So right now we will go. Okay, in this part, I want to explain briefly about cryptography. So cryptography is from Greek word, a combination of cryptos and graphene. So cryptos and graphene. So the meaning of cryptos is hidden and secret. Meanwhile, the meaning of graphene is to write or to study. So we can conclude from here, the meaning of the cryptography is to write a hidden or to write a secret message. So that means the cryptography. So right now we just ignore these three people. I will go to the next part first, and then we go back to these three people because I need to explain you something. Okay, so right now we are the another part. So in cryptography, there are two things that are important. The first one is encryption and decryption. So why we have left here? Because I want to indicate that encryption and decryption need each other together to make successful decryptography. So encryption, what is encryption? Encryption is a process to change a readable form into an unreadable form. Meanwhile, decryption is a process to change unreadable form into a readable form. So that is the function of encryption and decryption. So we will go back to the three people. Okay, so right now we have three people here. Right? We have three people. So what's the point of having these three people? You might be wondering why we need cryptography. So I just want to briefly explain the process of encryption and decryption, so you will see why and the reason of we need the encryption and decryption. So here we will see that three people, A, B, and C. Let's say A and B want to exchange message, but they don't want C to know what is the content. So A will encrypt the message into an unreadable form and send it to B, and B will receive the unreadable form and change the unreadable form into a readable form by using a key or decrypt it. So that is the flow. But if C want to retrieve the message, he will retrieve the unreadable form. And if he retrieve the unreadable form, he will never can translate it because he doesn't have the key and the decrypt key. So that is what I can say. I briefly explain about how cryptography is happen. So we go to the next part where we will solve our problem. Okay, right now in front of us is the problem. So our problem is how can we change linear algebra into an unreadable form and change it back to a readable form. So we need to use the encryption and decryption. So in this part I will show to you about how can we use it. So first thing is we need to change the linear algebra into a numeric. You must be wondering where I get this number. It's easy. I just get this number from this table. It is called alphanumeric substitution table. So as you can see, okay, we have 0 until 27. So 0 indicates a blank space. A until Z is 1 until 26 indicates A until Z. Meanwhile, 27 indicates a full stop. So that's how we can change the number from the alphabet into a numeric. And now we have 0 to indicate a blank space and full stop to indicate 37. So I just add these two things so we can use the whole numeric table. Okay, so we go to the next part, what we should do. Okay, so in our next part we will change this number, we will arrange it into a matrix with a 3 column. You might be wondering why 3 column. Actually, it doesn't have any circumstances. You can choose your choice. If you want to have 4 columns, 5 columns, is up to you. But I recommend 3 columns because it will be easier for you to make this process. So in front of you right now, we have a matrix that is called matrix A. We go to the next part. Okay, so our next part is, this is I don't know what to say, but maybe I will call it as a formula, encryption formula. You need a matrix A to multiply with the key. So we have matrix A, we have the key, multiply, we get the unreadable form. Sorry for that mistakes. Unreadable form. So the key, you might be wondering where I get the key. So this key can be any number you want. So I will explain it in this part. So we will go to the next part where I explain the key. So here we have the key. In order to create the key, you must follow these 4 steps. These 4 characteristics must have in the key. If this 4 doesn't have in the key, you can't do the encryption. So let's go to the first characteristic. The first one is can be random numbers. Yes, it can be any random numbers you want. Okay, go to the next. The matrix must be invertible. You can choose any number, but with one condition. It need to be invertible. It can be inverse. That's important. So we go to the next one, the third one. The third one, the key must have the same amount of column with the matrix you want to multiply. As we have here is matrix A have 3 columns, so our key also need to be 3 column. And the last one is must be a square matrix. So your key must be a square matrix. So you have 3 columns, so you also will have 3 rows. So this 3 is important for you. That's how you can create your key or encryption key. We go to the next part. As you know, this is how we get the unreadable key. Our unreadable key. So how we want to read it? In order to read the unreadable form, you need to decrypt the key. To decrypt the matrix. So this is the process of decryption. Okay. Okay. So here are the decryption method. How is decryption happen? Actually, decryption just have the same process as the encryption. You still need to multiply the unreadable form with the key. But right now, you don't have the same key because the key before is another key. So you multiply by this key and you will get the readable form, the matrix A. So where do I get the key, the decryption key? The key is, the decryption key I get is from this. So how? So, as I say, the characteristic of the key must be inverse, must be invertible. So here we are. We need to inverse the key into its inverse matrix. So that's how we get the decryption key. Okay? It's very simple, not too complicated. So that's how we get the matrix. So the last part is easy. We just need to arrange it into a straight line so we can translate it. So I will show you. Okay, so you just arrange it like this. So just a tips. If you want to arrange it, make sure if your matrix have 0, right now you have 0, you just arrange it from 12, 9, 14, 5, 1, 18 until 0. After the number after the 0, you start into another sentence, a new sentence, because the 0 is indicates the blank space. So your message have a blank space, so you will not complicated it. Okay. So here we are. We have the number. So right now we just prefer to our alphanumeric table. By referring this alphanumeric table, you will get the answer. So the number 12 indicates L, 9 indicates I, 14 N, 5E, 1A, 18R, 0 a blank space, and then 1A, 12L, 7G, 5E, 2B, 18R, 1A, and then a full stop. So that's how you get your message. So that's all in my part. So I hope you will make a good use of this method, and I hope you enjoy my video. Thank you.
Assalamualaikum, my name is Muhammad Shafiq and I want to give a conclusion for our project. So, what we can conclude is this method is very suitable to hide data from unauthorized user. We use encryption method where we multiply the matrix A with the key to get the ciphertext. And then, if we want to decrypt the ciphertext, we inverse the key and multiply it with the ciphertext and we will get the matrix A. This method is very powerful even though it is very simple because there is no limitation of length for the message, and determining matrix A is impossible if we do not know the key matrix. So from the result, it shows that matrices is a great tool to hide data and storage data. So the next one is I want to give acknowledgement to my fellow members. The first one is our group leader, Zaire. He is responsible to explain the problem solution. He shows the step and process of the method. Into the next member, we got Adam. He is our video editor and he made the introduction and descriptive title. The third member is Aiman. He is in charge of presenting the problem statement. Lastly is myself. I am the one who made the conclusion and also describing everyone's role.